there are two kinds of switches. So who wants to go first? What are the two kinds of switches that we've got?
A layer 2 switch and does
Yep.
just switching, and layer 3 that does switching and routing.
Yeah, good one. Two kinds of switches. There's layer 2 switches that just does switching.
I have to get my answers out while there's still answers available that I know.
Don't worry, don't worry. Actually, Mark, we're just joking, right? You don't need
I
to.
know, I know. It's just,
Oh,
it's
okay. I
all
think I
fun.
think my screen share stopped. Sorry. Uh, oh, oh, screen share, screen share again. Yeah. Okay. There we go. Yeah. So layer 2 switches are just the switching, and layer 3 switches. Is there any other differences between these two? Layer 2 switches and layer 3 switches. Apart from this one does switching, this one does switching and routing. I mean, that's like the core differences, but any other thing or any other thing that anyone wants to add. Alex, do you want to add anything?
On a layer 3 switch, you can add an IP address to an interface rather than a VLAN.
Yep, good one. So that's part of that also. So can add an IP address to an interface. Yep, good one. Whereas on this one, can we add an IP address to an interface on this one?
No, just
Only
VLAN.
on the VLANs, yeah.
On the VLANs, what do you mean by on the VLANs?
Configured on the interface VLAN.
On the interface VLAN, and how many of them can we have?
48.
No, sorry, Kevin, what did you say?
I think it's 48. I'm not sure. I'm just
48
guessing.
on this one. Oh, let me put it another way. How many can we have functioning at the same time?
I'm
As
only
many
on.
VLANs as there is.
Right.
Yeah, okay. So who agrees with that? Who disagrees with that? As many VLANs as there are. Mark, do you agree with that? Yep. Mark, do you agree or do you disagree? So just expanding on what, yeah, I said I was version dependent. So expanding on what you said, or the answer that you gave, that layer 2 switches just does switching, layer 3 switches does switching and routing. So Alex added that, yeah, on layer 3 switches we can add IP addresses to interface to an interface, IP address to an interface. But on layer 2 switches we can only add IP address to interface VLANs. And the next question is, so how many VLANs, how many of those interface VLANs can we have functioning at the same time on a layer 2 switch?
All right, okay. So I want to get us clear somewhere. You said
Yeah,
something like you said layer 3 switches. You mean like multi-layer switches, right?
yeah,
Okay, all
yeah,
right. Just want to make sure that you're not talking about a router and
yeah,
then
yeah.
okay.
So
Are you sure you can actually configure an IP address on an interface and not the VLAN for multi-layer switches
for multi-layer switches, does anyone want to answer that? Can we configure an IP address on an interface on multi-layer switches
instead of a VLAN?
instead of the VLAN? So Alex, what do you think?
Hmm.
I know GNS3 allows you to do that, like configure an interface for F01, F0, F00, F01, but I'm not sure whether that actually is not a GNS feature, GNS3
Mm,
feature of the real life thing.
mm. uh, uh, Only on interface VLANs. So people are quiet. Alex, you're quiet. Kerry.
I,
Yeah.
I am learning.
Mark, what do you think?
I would say yeah.
Yeah,
I mean,
yeah. I mean, I would say yes also. So I second Mark and Powell. So yeah, it's possible on multi-layer switches we can configure IP addresses on the interfaces themselves. So the interfaces on multi-layer switches can be either layer 2 interfaces or layer 3 interfaces. And Powell is right in saying the way we convert them to layer 3 interfaces is the no switch port command. So let's say I bring up a multi-layer switch, and we bring up a multi-layer switch. By the way, does anyone want to give, while we're bringing that up, example of layer 2 switch models, Cisco switch models, and layer 3 Cisco switch models? Anyone? Yeah, anyone?
29 something. I don't know what they're
29, yeah, you're right. 29 what? Anyone?
60, 50,
Yep,
something.
good one. 2950 is one. 2960 is one. Which other one?
That's a great question.
Which other one do we have? Layer 2 switches, layer 2 switch models. Which ones?
Can it
So
be
Mark has
anything in
given
the
us two.
2000 series?
Yeah, you're right. So usually, like anything that starts with a 2 is a layer 2 switch. Anything that starts with a 3 is a layer 3 switch. But then there are layer 3 switches that don't start with 3 also.
Mm.
Yeah. So having said that, so which model are layer 3 switches that you know of?
3550.
Yeah, good one. 3550 is a good one. But that's reaching end of life. So which is the one that replaced 2950 or 3550?
I
Yeah,
don't know.
3560.
Powell says 3850.
Yeah, right. Um, there are the bigger switches which are like they don't start with a 3, but they are also multi-layer switches, like the 4500 series, I think the 6000 series. Is it six? Yeah, I think there's 6000 series also. So they are layer 3 switches, even though they don't start with a 3. But typically, anything that starts with a 2 is a layer 2 switch. Anything that starts with
Okay.
a 3 is a layer 3 switch. But then there are some that are layer 3 switches that don't start with a 2 or a 3. Sorry, that don't start with a 3. And okay, yeah. So let's bring up packet tracer again, and let's bring up a sample layer 3 switch. And on this switch, on the interface on this switch, we want to see if we can configure an IP address on the interface on this switch. So if we go, then if I go IP address, now it's not allowing me to type in an IP address on this interface. And does anyone know why?
Is that a layer 3 switch?
Yeah, it is.
Okay.
It's because
You've
IP
not
routing is
configured.
not enabled.
Sorry,
Mm,
what's that? What did you say again, Alex?
IP routing is not enabled.
let's check that. Type do show do show no do show. What is it? Do show protocol should show whether we have IP address IP for enabled. So internet IP routing is enabled. So
Yep.
strike one.
So, so which
Isn't
other
it
reason?
do
Is the
show
no
IP
is the
route?
command is the command that you talked about the
Y-
no
Switch
switch
port,
port
yeah.
protocol?
So yeah, so
Yeah.
actually, let me give a clue, guys. If we're not sure, just look at Powell's answer
Yeah.
in the chat window.
IP
that
protocol?
that's what I
No,
do.
no switch port would enable you to be able to configure IP there. Which was
Yeah,
what I was saying that
yeah,
you have to be. I was trying to command that to comment that on its own
yeah,
without you putting that information in there, you
yeah.
can't configure IP.
Yeah. So basically, by default, so on layer 3 switches, let's see. So back again. On layer 3 switches, there are different kinds of interfaces or ports. So if I go to 22, so on layer 3 switches, and there are different kinds of interfaces or ports. So the first one are layer 2 ports, which is by default, that's the state of the port on a layer 3 switch. By default, they are layer 2. So that's the reason why when we went to this switch and we went to an interface, we couldn't type in an IP address by default, because by default, they are all layer 2 ports. But then we can make them layer 3 ports by using the command no switch port command. And now we can type IP address, 192.168.1.1, and that it accepts that now. So now it's a layer 3 port. So they are layer 2 port by default, and then they are layer 3 ports, which we can configure by using the no switch port command. And then what's the last kind of port on layer 3 switches?
The
Yep, what's the last kind of port on layer 3?
Where did you
virtual,
type that again?
virtual port.
Sorry?
No, I was just say, where did you type that when you go inside the interface? No switch port, or
Yes. So that's under the interface. So that's under the interface.
Console ports?
No, so it's on the
Virtual
port
ports. I don't know.
Okay, you said
A
console
routing
port.
port.
Well, you actually technically you're right. So maybe you can say there are more than three. There are more than three types of ports. So in terms of
Because
console
I
ports,
was
you're
I
right.
was like depends on what you have on that route on that layer.
Yeah, so console port is actually, yeah, so you're right technically. But there's another one that we're looking for that matters in terms of like routing and switching, which is the switched virtual interface. Does anyone know what a switched virtual interface is? Called SVI. What is a switched virtual interface?
It's a VLAN with an IP address.
Exactly, it's a VLAN. Well, I won't say it's a VLAN with an IP address. I would rather say it's a logical layer 3 interface. So you can give it an IP address because it's layer 3, but it's basically a logical layer 3 interface. So I can go, it's the same, it's the equivalent of what you mentioned on a layer 2 switch, where we can go on a layer 2 switch and say things like, if we go exit and say things like interface VLAN 1. That is a switched virtual interface, and it's a logical layer 3 interface. It's not physical, it's not something we can see and touch and plug a cable into, but it exists inside the switch. And I can give it an IP address and say IP address because it's a layer 3 interface, only that it's logical. But on a switch, Powell said it depends on, because this what started this discussion is that we said how many SVIs or interface VLANs can we have on a layer 2 switch functioning at the same time? Powell said it depends on the iOS version. Actually, I'm not, because I was under the impression that we can only have one functioning layer one functioning layer 3 interface on a layer 2 switch. So that was so Power, are you saying that there's a layer 2 switch that we can have more than one functioning layer 3
We can
interface?
test it out. Let's test it out. Let's
So
go
yeah,
to multiple ports and do no switch port and
yeah,
see how many interfaces we can actually have running.
yeah,
Because I was of opinion that maybe normally we do that for like management, but
yeah,
I could
Yeah,
be
I'm
wrong.
pretty sure that you can have more than one, but you only really need one configured.
yeah. No, you can have more than one, but again, the defining thing is functioning, because normally
How many will be
if you
working at the
enable
same?
one, it disables the other.
Okay, let's do
Normally,
let's do it on one. Let's do we'll do it on two ports
yeah, and
and
let's
then
do
do
it
no
on,
shot on them and do show protocol and see what we
yeah.
get.
So let's go conft interface VLAN 1, which is like the default one, and then let's say IP address 192.168.1.1
I think you can have multiple really.
Yeah, I mean, because I was under the impression you can only have one. Because I've definitely seen a demonstration where you have one, you enable the other one, and then instantly it disables the other one that was enabled. So if you have interface VLAN 1, I can go ahead and have interface VLAN 10 and give interface VLAN 10 an IP address of this. But then Once
Let's
interface VLAN 10 gets enabled, it automatically disables VLAN 1.
all right. Let's enable both.
So um, let's see. Show.
We have to assign ports to it though,
Yes,
right?
yeah. So that's one thing that we need to be careful of. So if we go down, yeah. So we got
Well,
administrator data.
you have to create VLAN 10,
Yeah,
otherwise it will be down.
yeah.
Yeah.
Um,
Yeah. You have
VLAN
to create
10.
VLAN 10. Yeah.
So let's say
Let's
interface
do show
VLAN 1.
again.
Yeah. Um, um, so, but they've
See,
got
they are both up.
into it. Yeah, they're both up. But then the issue is this a situation for because it's packet tracer, or is this a
No,
situation for a real
no,
switch?
I can do it on JNS3.
Both of them on a not in a layer 3 switch, on a layer
I
2
know.
switch.
A multi-layer switch. You
No,
can always.
not multi-layer switch. You can have multiple. Talking about a
Oh,
layer
okay.
2 switch.
Well, what do you mean by layer 2 switch? Because
Yeah,
in GNS3 only allows
yeah,
you to use
exactly.
like the
To
routing
multi-layer. Yeah,
iOS
exactly.
on, so it's multi-layer. So
Yeah,
that's what I'm like.
yeah. So on multi-layer switches, we can have multiple switch virtual interfaces.
Hmm.
But on layer 2 switches, so Powell said it depends on the iOS version. But I was under the
Exactly.
impression that we can only have one SVI enabled on a layer 2 switch. That's the impression that I was under. I can only have one switched virtual interface enabled.
I
Um,
think this actually, even on packet tracer, if it's going to be on, I don't think it's exactly. I think it's going. It depends on the as Powell said, depends on the iOS that you're using. If the iOS does not allow you to have more than one example for, like, let's say management,
mhm.
then that you can only have one management, then that's it. There's nothing you can do about that. But if it does allow you to have more than one, then uh, we can actually have that.
Let's see. Yeah, so that I mean, but this is 5 years ago, so so it could be that this is outdated information.
Well,
Yeah,
I
so
just
the
tried to
power
do
said
it
yeah,
on I
because
tried to do it on my 2950,
yeah,
and it took down the interface I had.
yeah.
So I
So
think that it took down my VLAN.
yeah, exactly. So that I mean, so it could be different on 2960. Remember, so because I've definitely I remember when I was doing the CCNA training in London, this was one of the things the instructor showed us to say, look at this. This is a layer 2 switch. I've got interface VLAN 1 working on it. Then it goes and enables interface VLAN 20 or something like that. Put a port in it and it automatically disables one because you can only have one layer 3 interface on a layer 2 switch. So you can create interface.
Technically, you said, are you talking about one interface VLAN,
Yeah, that is working.
or are you talking about one interface? Because what I'm trying to say is that if you have like if you configure interface VLAN
Mhm,
and then you go to the port and you type in no switch port,
mhm.
if you type in no switch port and you configure an IP address there too, will that take down the interface VLAN? Is
So
my
again,
question.
this is talking about layer 3 switches. So we're talking about layer 2 switches.
Oh, okay. So
So
they are two. Oh,
yeah,
okay. All right.
so on
I
a
get it.
layer 2 switch, which is like a switch that doesn't do routing or anything like that with the 2950s, the 2960s.
Yeah, you're right. So
So
only
on
one.
yeah,
Only one will be.
so because that's what this guy is saying, he says since the layer 2 switch, you can't have more than one SVI, so it automatically shuts the existing SVI interface if you configure a new one. You need
It makes sense.
yeah, so you need the layer 2 switch, yeah.
Mm.
Any layer 2 switch can only have one SVI. To have more, you will need the layer 3 switch. So layer 3 switch can
That's it.
support multiple, but again, this could be outdated information. But
No,
when
no, it's not outdated. Think
yeah,
about it. Layer two. If all you're doing is layer two, that means you're forwarding frames. That's it.
yeah,
And the only routing you're going to be doing is actually just next up
management,
before gateway,
yeah, or just management,
or management.
yeah,
Exactly. So you don't really need to. You don't need more than one SPI.
yeah,
So
yeah. So that's one thing to watch out for because if you're on the layer 2 switch and you go interface, if you're going to use VLAN 10 for your management, stick to it and configure VLAN 10. But because if you go on it and all of a sudden enable another SVI, it disables the existing one. So that's one thing to watch out for. So again, Start at beginning. Interface VLANs. How many can we have? Yeah, we can have many, but only one. Okay, that doesn't look good. So let's go up here. So we can have many, but only one functioning at once. So only one of them functioning at the same time. Yeah. So that's one thing to take note of. So yeah, on layer 3 switch, we can have multiple. So we have the layer 2 port on layer 3 switch by default, or the port layer 2 port. Then we can change them into layer 3 port by using the no switch port command. Then we have the switched virtual interface, which is basically a logical layer 3 interface, and we can have many on a layer 3 switch. Okay, so let's go a step further from this. And a step further is um, what's like the main purpose of using a layer? Why, as a network administrator, will you introduce a layer 3 switch into your network? So you've been given a task to, to set up a network for your branch offices, and you're going to, the equipment that you buy, you want to raise a purchase order for them, and you're ordering your layer 2 switches that will be like your access switches. Then you have to make a decision to say, okay, and this one, on the other hand, you've got your ISP router here, but there must be a device in between these ones and your ISP router. So why as a network administrator will you go for a multi-layer switch rather than going for a router? What's the reason? Why?
Because it takes some overhead off of your core layer router.
What do you mean? Explain it more. So what do you mean by it takes the overhead off?
So that way that it doesn't have to go to your core layer just to go back down through the distribution and back to the access layer.
Nice one, very nice one. So what you're saying, let me write it down. The word you use to take the overhead of the core, right? Yeah. So basically, if I get it right, what you're saying is you're talking about if you have multiple VLANs, right? And what you're saying is that if you have multiple VLANs on this switch and they are all connected to, this one is connected to this guy, this one is connected to this guy, this one is connected here. So what you're saying is, let's say you've got VLAN 10 and VLAN 20 on this guy. What you're saying is if someone on VLAN 10, so there's a computer here that's on VLAN 10, and there's a computer here that's on VLAN 20. If someone on VLAN 10 wants to talk to someone on VLAN 20, what you're saying is, let's have a small packet. Yeah. So the packet has to travel down to the core router, right? And then travel back up to go to this guy. Is that what you're saying?
Yep.
Yeah, good one. So that's a good point. So yeah, good point. So to take the overhead of the core. So what other reason would you go for a layer 3 switch rather than a router on your network? Any other reason, Kevin? What reason would you go? What's the reason? So you're making a decision as to which equipment you purchase and why you're purchasing this equipment. So would you rather go for a router on your network, or would you rather go for a multi-layer switch, and why?
Not sure at all.
Yep, no problems. Yep. What about Mark?
I'll back up Carrie's answer. I support you all the way on that.
no, no, no problems, no problems, Mark.
I don't know. I mean, is cost involved? Is that one of the factors?
Yeah.
I don't know. I mean, I
Yeah.
don't have an answer.
Yeah.
I'm sure they would be just as expensive as just buying a router, right?
Yep. They
Maybe
are.
more.
Yep. So, what about Maya? What's like your answer to that? So,
Oh, why? Well, cost, you're right. One, routers have more features like routing protocols and all that, so it might be more costly with that. But if you're just doing like basic routing, like static routing or stuff like that on your layer 3 switch or stuff like that, it's just that is not because pretty much that might actually be as a physical cost in terms of cash. The router might be more expensive based on features. That's one thing that can be enabled on it. Two is that the
So
switch itself has a switching fabric
let me ask a
that
question
makes
in
it
terms
work
of this.
faster.
So does the router, does it have more features than a layer 3 switch? Is there any feature that the router supports that the layer 3 switch doesn't support?
Things like IDS, things like maybe higher server load balancing, link load balancing. There are features like that I doubt. I'm not too sure about the Cisco switches, but usually what I notice is that the um, other vendors
Mhm.
they usually make them available on their routers or high-end multi-layer, like I said, multi-layer switches than just L3 switches.
Mhm.
So L3 switches usually should be basic routing, maybe like IP-based kind of routing or stuff like that.
Yeah. My own
So,
impression was that yeah, so Power said yeah, you can we I because I also thought that we could put, because I know the multi-layer switches for Cisco, like the big ones like the
oh,
6500,
okay.
4500, 4500, where you have the ISRs and you can plug in line cards. And not only that, we can buy modules. For example, I think there's an IDS module for the big Cisco switches, which are multi-layer
Oh,
switches
okay.
also.
So you can do that now. Okay, I
Yeah,
didn't know
I,
that.
I mean that's the impression I was under. Power, what do you think? Is that yeah? Okay, Power
Yeah,
said
I think Powell agrees with you.
yeah,
Yeah, because
yeah,
in the past, really, what they did was that they made routers. From my understanding, that they made more routers
yeah.
have you can use the same code, but you can't just enable it. And
Mm-hmm,
maybe routers will have you can enable it to support
mm-hmm,
more like let's say like maybe IDS, maybe we may support more numbers than
yeah,
what will support on some switches.
mm-hmm,
You understand? Because they expect you to do less on the switches than to do on the router. But yeah, you're right.
mm-hmm,
And if we look at it from a design perspective, why would we need core routing? What do we want to be doing in core routing?
mm-hmm,
So, well, but let me just put it this way. This is where I look at it,
yeah,
really. I look at it as in layer 3 switches
yeah,
should be like downstream routers. If you
mm-hmm,
look at them like downstream routers
mm-hmm,
and look at core routers as like your, or actual routers as like your core router,
mm-hmm,
then it will be easier to segregate what one does for the or why we should buy one for the other. So if you want to be routing
mm-hmm,
or you want to do some routing near the end or as close to the edge
mm-hmm,
of the network as possible, when I say edge of the network, guys, I'm talking about as close to the endpoints like the printers, the PCs,
mm-hmm,
all the other devices. Yes, use I think you should use L3. But if you need to route it, like let's say you want to do BGP
mm-hmm.
and other stuff like that, you want to route them outside and do a lot of core routing, then you need to buy a router instead for that.
Actually, like yeah, I mean, yeah, that's a good viewpoint. But for my own opinion, I would have, I mean, like one of the reasons why I know we use a layer 3 switch where I currently work rather than using a router.
Mhm.
Because actually, like a lot of it, from my own understanding, again, this needs to be confirmed. There's no feature that the router supports that the layer 3 switch doesn't support. Because
Okay.
if you go online and we get let's get something like maybe a Cisco 4500
Mhm.
or Cisco 4500 um image. Yeah, just one of these ones where we can have so they've got like multiple slots available and they've got multiple, you can see these things that are coming out. So you can
Yeah.
actually plug like lots of
Yeah,
modules
it
into
looks
them.
like the 8600
Yeah,
or Notel routers
yeah,
with
yeah,
multiple
exactly. Yeah,
slots.
yeah.
Hmm.
And they've got, for example, you can have um like anything basically, like if there's a module for it, you can plug it
Hmm.
into a Cisco multi-layer switch. So
Hmm.
like what Power mentioned, we can have redundant supervisor engines. So what that means is that the main engine of the switch itself, the thing that is doing all the processes, you can have two of it. So that if one of it fails, the other one is still running. And the one that fails,
Mm-hmm.
Cisco will send you a replacement. You can plug it in while it's still running. So you have like
Yeah,
things
hot
like that.
swappable.
Yes, exactly, all swappable. So basically, the main reason why I'll go for a multi-layer switch rather than a router in the core, even in the core of my network, is number one, the thing that Maiwa touched on it briefly, which is the design. Because if you think about it, I have this switch here, I have VLAN 10 and VLAN 20 on it, right? I have this switch here, I have VLAN 10 and VLAN 20 on it, and VLAN 20 on this one. And I have this last switch, which also has VLAN 10 and VLAN 20 on it also. But think about this. If for inter-VLAN communication, there has to be layer 3, right?
Mm-hmm.
There has to be layer 3. So which means if this guy is connected to this one, I have to configure something like router on a stick, right? And
Yes.
router on a stick
Mhm.
will go and say, well, this port, what router on a stick will basically say is, this port is a trunk port here, this one here. And
Mhm.
this port can carry VLAN 10 and VLAN 20. Then I'll go
Mhm.
on this one and configure sub-interfaces and say, well,
Yeah.
these sub-interfaces can carry VLAN 10 and VLAN 20. And I have to do the same for all these ports and do sub-interface here and come here and do sub-interface here, 10 and 20. And then do sub-interfaces here also, which is 10 and 20. And it ties in with what Alex said in the beginning. Because if this guy, even though they're on the same switch, if this guy wants to send a packet to this guy that is on a separate VLAN, it has to go down this line, go to the sub-interface, get passed back up. Even though they're talking on the same switch. And it's the same thing. He has to go down here and then come back up. Now, the issue with that, you say, what's the issue with that? The issue is that is this link is limited. You know, how long can you go on a normal router? You can probably get up to like, I've not seen 10 gig port on a router before. Is there yeah, I'm not sure. I think that'll probably be wrong. I think that'll probably be wrong, but I've not seen any port. I've
There
probably seen like,
probably is, but they're out of our price range.
yeah, I mean, the highest I've seen on a router is like 1 gig port.
Yeah.
So I've not seen like a 10 gig port on the router. On switches, you gotta have more. But so basically, this is like a bottleneck because everything that has to travel to this guy is limited by this port right here. That's a bottleneck right there. So this guy too is on VLAN 10, the other guy is on VLAN 20. Wants to send information to the computer next to it. It goes down here. It's limited to this port, to the speed on this port, and then it comes back up, and then it goes back here, and then it gets passed to this guy. And then if you think about it, I have to have a router with multiple interface, right? That means I have to go for like a really big router, especially if I have like multiple access switches in my environment, right?
Well, if you're doing router on a stick, you can create the virtual interface and
Yeah.
then do the encapsulation. But
So again, router on a switch is not virtual interface, it's just sub interfaces.
yeah,
So it just sub interfaces on this one. So it's limited by this port here. But then let's say the same situation, let's cancel this whole situation and let's say rather than using this, we've decided we're going to use a layer 3 switch instead. So we have a layer 3 switch. We have this one connected to this one. We have this one connected to this one. We have this one connected to this one. Now this port on this layer 3 switch, it can be layer 2 or layer 3. I'll leave this port as layer 2. So this would be a layer 2 port. I'll leave this port as also layer 2. And I'll leave this port as also layer 2. And one thing that I can now introduce is I can introduce ether channels. Because now, if I'm connecting this one to this one, I can't introduce ether channels. But with this one,
Mhm.
I can bundle multiple, because they are both layer 2 switch ports, right? I can
Mhm.
bundle multiple ports to act as a single port on this guy and bundle multiple ports to act as a switch port, as a port, as one single switch port on this guy also. So I can have multiple switch ports bundled together, connecting to this layer 2 port right here. And
Can
then
you also do spanning tree and then have one for VLAN 10, one for VLAN 20?
yeah, exactly. Again, good one. We can also do spanning tree on that. But then here's the advantage to that is that rather than now having sub interfaces on this one, these lines will just basically be layer 2 trunk lines. I will now have SVIs on this one to say interface VLAN 10 and interface VLAN 20. Now the thing with this interface VLAN 10 and interface VLAN 20 is they live in something here which is referred to as like the switch backplane or the switch fabric. And the processing here is really fast. We're talking about 60 gigs per second, 80 gigs per second, more than that. So this packet of frame can basically come here, come through all these ether channels, come to this guy, go here, and then get processed in this highly fast backplane switch fabric here, and then gets passed out, immediately. You get the point.
Mhm.
Does anyone have anything like any question or stuff regarding that?
Nope.
Anything? Mawa, what's your thought on that?
Yeah, that's exactly what I was talking about. That
Yep.
multi-layer switches give you a switching fabric at the backplane and makes it work faster than if you're just using a router.
Yeah.
And yeah, the fact that you can increase your bandwidth across the from like these layer 2 switches, you can
Yep.
increase your bandwidth using ether channel,
Yeah.
makes it much more easy to work with,
Yeah.
and you can actually have all that. But you can see all this
Mm,
that you designed and you put over there
mm,
in, let's say, a huge enterprise, let's say like Microsoft, where
yeah.
they are scattered all over the whole regions.
Mm,
Like this is great for just maybe a small enterprise or a big enterprise that has only one location.
mm,
At the edge, at the edge near the PCs,
mm,
you can have the inter switches there. But if you're now going to like be dealing with routing across maybe ISPs or different IP
mhm,
public IP
yeah.
spaces, then you're doing all that. You may need to use a core router in there
Yeah.
to do that routing there.
Yeah, actually, like on the core of our network, where I currently work, on the core of our network, we use a layer 3 switch. It
Oh,
does,
use a
it,
layer
yeah,
two
it,
switch.
yeah, a layer 3 switch. It does
Okay.
BGP. It does every routing protocol, all the normal routing protocols.
All
And
right.
I'm
So
not, yeah, carry on, Mara, sorry.
well, if that's the, as I said, you may ask and confirm though,
Yeah,
because if it is that layer two switch, layer L3 switches are doing exactly the same thing as routers are doing,
yeah.
then they should stop making routers.
So, like, I'm not.
There's no business sense. It's true.
Yeah,
There's no
yeah,
business
yeah.
sense to
Yo,
make routers
that's a
because
good
layer
point.
three
I think that's
switches
a
are
really
cheaper.
valid point. Yeah, that's a really valid
Layer
point.
three, layer three. If you check online, layer three
Yeah.
switches are actually cheaper than router,
Mm.
than actual routers.
The layer 3 switches.
L3 switches I think I think are cheaper than actual routers.
I think they're more expensive actually.
For
Yeah.
the same number of ports,
Mm,
the routers are more expensive.
mm,
So
Well,
I'm talking about a
if
router with
you're
maybe one port or two ports.
mm,
I'm talking about routers with multiple ports.
mm. So,
because
Because
you
core
can't get a
routers,
router with
no,
a module interface.
take note of this. Core routers actually should have like larger amounts of memory and CPU utilizations or
mm,
CPU capacity
yeah.
than switches.
Mm-mm,
The switches uses the fabric. It's actually physical. Routing for the core routers is more software, so they need more CPU memory.
mm-hmm.
And maybe CPU and memory is now much cheaper. So, but that was back in the day anyway.
Mm-hmm.
Routers were more
Yeah.
expensive than their two switches.
So,
Maybe it has turned around now.
yeah, actually, my wife brought up a really good point. I've never thought of that point before. That it's a really good point because so what's like the main distinguishing reason why ISPs we use routers rather than layer 3 switches. But with this one, but what I can say is that with this one, even with Cisco's enterprise framework, which is like Cisco's recommendation for a business to design their network, their internal network. is that when it comes to your core, you use layer 3 switches. That's like Cisco's recommendation for this one. But that's a really valid point, which I've never thought of before to say. So if layer 3 switches can basically do the same thing that routers are doing, so what exactly is the distinguishing sales point for a router? Which is a really valid point, I think.
Are you trying to sell us one?
Sorry, what did you say? What did you say, Mark?
I said, are you trying to sell us one?
Which, as in, no, I didn't get the question. Sorry.
No, you said what's a valid sales point or
Yeah,
something like that.
yes. So exactly. So what's like the valid point to say, use this, use and the router. Why ISPs will go for the router rather than using layer 3 switches? Powell, any thought about that? It does matter in DC that's why we even have separate series of DC switches. One more. For example, you cannot put ADSL card in switch. Okay, I see. Okay. So
So those are
basically,
the features I was talking about. That
yeah.
there's
So
some things you can't
basically,
do on
there are still
switches.
some features. Yeah. Yeah. Okay.
Powell's like
Okay, it says
Wikipedia.
read above. It says layer 3 switches are much faster than router. It does matter in DC. That's why we even have separate series of DC switches. And one more thing, Ethernet still evolve, and now we have 1 gig, 2.5 gig, 4 gig, 10 gig, 16 gig speed. And so there will be more common now. Bottleneck is backplane. That's why we have our subscriptions. Fabric is different technology used in DC. Yeah. So yeah, we agree, Power. We agree that layer 3 switches are faster. But then, so basically, from what Marwa and Power has mentioned, the main distinguishing thing is even though layer 3 switches are faster, there are still some features that core the router supports that layer 3 switches still don't support. So actually, if not for like what Power said, which I'll need to research, I would have thought that you can put, ADSL cards on layer 3 switches. Sincerely, I would have thought that because basically there's really nothing that I mean I know we use it on the core of our network and it does like lot of stuff and we've got all kinds of ports, modules, put on it, installed on it, and all kinds of stuff. But yeah, okay, yeah, that's a good one.
I mean, I think it said they're more modular in design, right?
Yeah, but what about layer 3 switches? Are they not modular in
The three
design?
switches are actually modular. The way they are making them now,
Mm,
take note, I'm not saying layer three switches and just layer three switches. I'm talking
yeah,
about
the big ones.
multi-layer
Yeah,
switches.
yeah,
You understand?
the
So
45
that's why
gig.
you have to be careful. I keep saying multi-layer.
Mm,
If you just say layer three switch,
mm,
it means it only has an additional feature of being able to route.
mm,
You understand?
mm,
That's pure layer three.
mm,
Some routing can be done, in which case sometimes you find out that you can actually do OSPF, you can do NAT, but maybe the NAT table
mm,
allowed for you is smaller, because depending on the memory you have enabled, So, because every NAT table or every NAT entry you create or ACI,
mm,
not ACI really does, but every NAT ACI like you create for it or
mm,
static NAT and co takes some memory,
mm,
So it might be less. It may support all those features. It
mm,
may just support less of them,
mm,
depending on what the memory or CPU utilizations
yeah,
is available,
yeah,
or like ports that is available, or the kind of port that is available for that particular switch. But
yeah,
routers, as you said, the major thing, real thing is this: if you want speed,
yeah,
use a switch.
mm,
You understand?
yeah,
If you want some particular features
yeah,
that you can't get on the switch,
mm,
then maybe you have to go to a router.
yeah, yeah. Okay, good one. So yeah, I mean, is that point to me? I think that point is like, I mean, it's more clearer because there are some questions that have come up in that point that are really really interesting. So I'm not sure. Does anyone have a question regarding the things that we just discussed? So for Carlos that just joined, what we've been discussing is as network administrators, what's the reason why we want to use? So we have our network. What's the reason why we want to put maybe a layer 3 switch at the core of our network, uh, rather than putting a router? And the main thing that has come up in the discussion that we've had so far is that yeah, layer 3 switches are faster um, in terms of performance. And then like for example on we can use things like we can bond multiple uplinks together to make like a single virtual uplink and things like that. But then the other thing that came out also is that there are still um, some features that routers support that layer 3 switches don't support. So what's your own thought on that, Carlos? What's your thought on that? So why, as a network administrator, will you want to use maybe a layer 3 switch or a router, any which one, on your network?
Why would I want to use a layer 3 on my network? I mean,
So,
I
so,
need,
so
I
so
need
let's say
route.
you're given a task. You're like, Carlos, we have a new branch office, you know, go put the network in there. So you have to make the purchase order for the equipment that you'll be using for this network. So you've bought all your layer 2 switches, your access layer switches that your devices will connect to. But then you have to decide, okay, what will be at the core layer now? Will I use layer 3 switch or will I use a router? Which one will you use and what will be your reason or your justification for that? It's kind of like an interview
Probably,
question.
I mean, yeah, I mean, what I've seen usually is we use like layer 3 switches and we only use routers over like WAN or, I guess it's typical, but
Mhm.
why would I use one over the other?
Yeah.
Uh, I mean, if anywhere I see needed performance need, I guess we do layer 3 switch.
Hmm. Yeah. But what about in terms of features? Are the features that know that a router supports that layer 3 switches don't support? Because I'm not sure of many at all. I'm not even sure of any.
I'm not sure.
Yeah. So I think that's a good point. So we need to research that some more. But Alex, any questions regarding that? Kevin, any questions regarding that? And Mark,
No, no,
any
I'm good.
questions regarding that?
No, not really.
Yeah, good one. So yeah, so let's dig
Oh,
deep.
David, we
Yeah,
could
carry
ask
on.
that question. We could ask that question on router gods or NYC networkers and
Yeah.
let them go at it.
Yep, I'm sure. I'm sure we'll have a lot of fireworks. Okay. Yeah,
And
okay.
it will go on for days, I'm sure.
Yeah, okay. With this one then. So having said that, so let's dig a little bit deeper. When we talk about layer 3 switch, you know, as faster performance. So how does that work? How does it work that with a layer 3 switch has faster performance than a router? What makes layer 3 switches work that way, that they've got more performance than routers? Who wants to go for that first? Carlos, because you just joined, so.
Yeah, I'm not sure how true this is, but from what I hear is switches calculate more on hardware versus the router calculation would be more software based. But I
Yeah,
don't know how true that is.
yeah, that's right. That's absolutely right. So let's put that down. Let's be putting all these points down. So what Carlos has said is the switches calculate in hardware, whereas where routers, yep, calculate in software. Yep. Any other reasons that you think of why layer 3 switch, why it will have that much faster performance than a router? Alex.
Because it runs on ASICs.
Yep, good one. Good point. Good one. So now you have to explain to us what ASICs are. What's on ASICs so that we won't be confused.
It's basically hardware that's processing the information rather than software.
Yep, that's good enough. The information rather than software. Okay. Yeah. Any other reason why they do that? So so Alex, so can you explain how does A6 on the layer 3 switch, how does it do this? How does A6 on layer 3 switch, how does it process more information than the router does?
Uh, that's a good question.
So we have the A6 here. So So what exactly is that doing to make it faster? So you have the ASICs there, and then we have a router here, and you said this one is in software. So how exactly does it do this? So you have a device connected here. It wants to send packet out to a device connected here, and you have a device connected here that wants to send a packet out to a device connected here. How come this one does it faster than this one? What's going on inside this one that makes it do it faster than this one?
Because it doesn't have to be processed by the CPU as much.
Yep. So okay, yeah. So it said it doesn't have to be processed by the CPU that much. So again, good point. So let's put that down. It doesn't have to be processed by the CPU that much. So again, can you explain that? Okay, so let's start it this way. On the router, you have a packet, right? That's coming in. So we have this long packet that just came into this router. Can you talk us through what will happen for this packet to go through this router? What happens here for it to get to this other end? What exactly is going on?
Well, it depends on what process it's using. If it's using Ceph or the other ones, the two other ones, I don't remember what they are.
Yeah, okay. So that's a good point. So let's bring up another whiteboard because this one will help us to be introduced to this. So there are three different methods that packets can be processed. So there are three methods for packets to be processed. So what are those methods? I'm now not sure whether it's three or four. But
There's
I
three as
remember
far as
three.
I'm aware.
Yeah, I remember three. So so what are those methods? Kerry,
I
what are those methods?
think she said be right back.
Sorry, I didn't get that.
She said be right back.
Ah, okay, yeah. Sorry, I didn't see that. Yeah. Okay. So we have to go to our favorite guy, Mark.
Whoop, 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 whoop.
Yeah, you see, Mark, you've got a lot of supporters and stuff.
Oh, we woke him up.
So, Mark, there are three different methods that packets can be
Are you talking
processed.
to this Mark or the other Mark?
I'm not. I didn't. I didn't know. I didn't know that there's another Mark.
Let's see, three methods packets can be processed.
There could be
Is
more
it,
than three. I'm not sure, but I remember three.
I think there's only three.
isn't it the store and forward?
So that's like talking about the frames.
No, are those the three that you're talking about?
No, so those are talking about the frames. But if you mention that, we'll give you a pass. So if you mention the method for frame and processing, we'll give you a pass, and then we'll just deal with the packet by itself.
At least I
So
remember that part.
so what are the frame ones? What are the frame processing?
I know that there's Cisco Express Forwarding.
Yep. So let's put this one down. You have the Cisco Express forwarding, Ceph. Yeah. What else?
I've never heard of these.
Ah, no, don't worry, Matt. So the main point is this one is more like just to introduce, just so that you've heard of them.
Uh,
Then later when you hear of them in like class or in a textbook, you're like, yeah, I've heard of this before. It won't be
right.
something strange. Yeah. So we won't go into like details or something like that. It's just part of our discussion. Let's just mention it.
Okay.
Yeah. So what other methods of packet processing? Hmm? What that method? Yeah, okay. Before I mention it,
Fast switching and process switching.
yeah, good one. Fast switching and process switching.
And I don't know what this is. I'm just reading it.
So you're right. Process switching, fast switching, and Cisco Express forwarding. So what does process switching does? What does process switching? What does it do?
Everything gets processed by the CPU before it gets sent out.
Good one. So everything gets processed by the CPU. So let's explain that a bit. So a packet comes in now. So um, this packet that comes in, it goes to this port. On this port of this switch, there are two queues. There's the ingress queue and the egress queue, or the inbound and outbound queue. So there's a queue here that um, this, sorry, that this packet can be stored temporarily, and then packets that are coming in that the router has to process, and packets that the router has decided has to go out of this port can be put into this queue on this port. So it's like a little memory for each port. So this one gets put into this port, this queue on this port to say, hey, router, you need to process this. So this
Mm.
interface sends an interrupt to the CPU. So this router has a CPU here. Sends an interrupt to the CPU and says, hey, CPU, we've got something here that we need to process. CPU says, okay, yeah, send it to me and I'll take care of it. So if I can get this one working. Yeah, okay. Send it to me and I'll take care of it. So it sends it to the CPU. CPU looks at it and is like, oh, you want to send a packet to this destination. Okay, no problems. I'll send you to something called the root processor. So there's another one here called the root processor. So sends it to like the root processor. Just call it RP. And then the root processor does like the rest to say, okay, I'll look in the routing table to decide where to forward you. So I look in the routing table, it says forward you outside this port. So I'll put you on the egress queue on this port. So the root processor looks in the routing table. Then after looking in the routing table, it decides, oh, for me to forward you down this port, I'll need the MAC address of, the next up to forward it to. So it goes and does app, which involves the CPU, and then after getting the app, rewrites this packet, changes the destination MAC address because the IP, the source IP and destination IP are always the same. The destination and source MAC address may change. So changes the destination MAC address, changes the source MAC address, and then forwards it. All those processes involve this CPU right here. So again, the packet comes in, goes to this queue here, gets sent to the CPU, forwards to the root processor, does all the processing, looks up the routing table, decides where to forward it to, does app, rewrites the packet, forwards it out the port, and it goes to this guy. Whereas when we talk about the other method, what makes the layer 3 switching fast is this, is that on layer 3 switches, you have the ASICs and then you have the software. You have the ASICs and then you have the software. So the software is where what does which is the iOS, is what does things like the routing protocols and decides what the routing table will be like and does all that. So it does all these in software which involves processor, right? So this packet comes in, it basically goes through the same process that it went through down below. But the difference with this is that this layer 3 switch has something called ASICs on them. And the way the ASICs work is this. The ASICs have two separate caches or memory on them. Now again, you don't need to remember this. This is just so you've heard it before. One of them is called the forwarding information base, and the other is called the adjacency table. So you don't need to remember them just because it's just something that you need you've heard of them before, you're just aware, just an awareness. So it's got this one. The way the fib works is that once the software calculates what the routing table is, it will update all this information into this hardware cache on the switch. So all this information about this is the network, this is the next stop address. This is the next network. This is the next stop address. All those will be in the hardware cache here. And then instantly, once it's in the hardware cache, the switch will by itself start calculating. Yes, you can. So we'll talk. Yeah. So yes, we can power. So Pi is making a good point. So Yeah, that we can do that on the router, provided that we have to enable Ceph. Whereas on the layer 3 switch, we can't even disable Ceph, you know. Whereas on the router, you have to enable Ceph. On the layer 3 switch, you can't even disable it. So here's the way it works. So this one calculates the routing table and downloads it directly into this cache. Yeah. Whereas instantly as it's downloading it into this cache, this one is calculating, resolving the MAC addresses for the next stop. So let's say this one is like for anybody that's going to network 192.168.0.0, your next stop is 192.168.1.2. This one is instantly resolving the app address and storing it here. So this one will contain like all the layer 3 routing information. This one will contain all the layer 2 switching information. So that once a packet comes in, it doesn't even need to go into the CPU to start processing, send it to the root processor and then decide, okay, we need to do an app. It just goes to this guy. This guy looks straight in the fib table and say, hey, I have the next stop address for this guy. This guy goes, yeah, I already have the MAC address of the next stop address. And it just goes straight through the cache and boom, it goes out. It doesn't go to the CPU and start doing interrupts and start doing all that. It just goes here. The fib is automatically updated by the software side, which does the routing table. So the routing table is automatically updated on the fib. This guy is automatically calculating the layer 2 information so that if anything comes in, this guy just goes, yep, I know the destination. This one goes, yep, I know what the MAC address, for that one is. I'll quickly do a rewrite, change the source and destination MAC address, and boom, it's gone. It doesn't need to go through the CPU or anything. That is what makes it faster. Is that clear? Or is there any question regarding that? Now that's just generalizing it, but yeah, carry on.
Yeah, I wanted to ask a question, a
Yeah,
technical question,
yeah,
but it's not part of this.
yeah,
You said something rewrite over there, and I wanted it's a trick question.
yeah,
When a packet,
mm,
or let's say when a frame goes through a switch,
yes,
right?
yeah,
You mentioned it before. Remember, when a frame goes through a switch,
yeah.
do you change the um, source MAC address or destination MAC address information?
So it depends. No, the switch, right? So
Yeah,
that's a good
switch.
question. So
Layer 2 switch.
I know where my why is going. So that's a good question. So
Does it change that information?
so when it goes to a switch, does anyone want to answer that?
On a layer 2 switch, it won't.
It won't. That's correct.
Yeah,
When
good.
you're because it's just forwarding it. So it doesn't. It just looks at the forwarding table, sends it out, and records the source MAC address and port number that I saw it coming from
Yeah,
for layer 2 switch.
yeah.
How about a layer 3 switch?
Mhm.
What happens?
It would.
It would.
Yeah.
It
You're
depends.
correct.
It
No, it
depends.
doesn't. No, no, no. Well, it depends. If you're routing,
Mm,
you're right. If
Yeah,
you're routing,
yeah,
you would need to replace it.
yeah,
If you're not routing, it would just do a layer 2 function
yeah,
and that's it.
yeah.
So that when you said rewrite, I wanted us to remember what actually we are rewriting.
Yeah, good one. Yeah, because what I will actually mention is something known as transparent bridging. In other words, the switch is like a transparent device. You know, the layer 2 switch, sorry, is like a transparent device. The device on one hand doesn't know that actually there's a device in between me and the other hand. It's like I'm sending it out, it goes into this port, and the switch is like, based on the MAC address table, this device is on this other port. The device itself is not aware of that. It's transparent of it. So the switch doesn't make any changes to that. But then if we now talk about layer 3, if it's not going to another, yeah. So if it's not going to another network, then that's like where the writing goes in, where it has to change the source and the destination. But is that clear as to um how layer 3 switches are faster, or why? I mean, the basics of it, believe me, this is not like the end of it. This is not the end you hear of this. But at least the basics of how it does things faster, is that clear?
I thought Ceph was supposed to be equivalent to layer 3 switching.
So on that's a good point also, Alex. So on modern routers, you can actually use Ceph. So you can enable, so like Powell said, you can enable Ceph on modern routers.
Mhm.
Yeah. So you have to go, the normal Cisco way of enabling things. You go to the config mode and you go IPsec, and it enables it on a router. But on a switch, by default, it is enabled, and you cannot switch it off on a switch.
Yeah,
Powered
on
by.
both sides. On both sides, you still need to do the first packet that goes in has to be
So
processed
that one is
by
something. So
CPU.
that one, the first packet, that's a completely different one. That is, remember we mentioned three ways that packets are processed, right? On the one
Yeah.
where it does the first packet by CPU, that is this second one, which is considered a legacy method. This is an old method. Actually, this old method, it's just basically called multi-layer switching. That's exactly what it's called. It's called multi-layer switching. It's called fast switching. It's a legacy method. In other words, you've still got, your cache here, but it's not like this exact type of cache. What it will do is that you've got a cache on the switch here, and the switch will do this one in CPU first. So it's like, yeah, where are you going? Look it up in the routing table. Okay, you mean router with self? That one I'm not too sure about. I'm not too sure about. So are you saying that even if you enable self on a router, so that way it's no longer self then? Because self the
Yeah,
way, yeah,
you have to just process it like
yeah,
with this
with that.
ASIC.
Yeah, because self, the way I was reading about it, again, it could be wrong because many things I'm reading, I'm trying to understand.
No, self should be self on both sides. It
Yeah,
doesn't matter.
yeah. So basically, this one will go, this one, the routing table will go, oh, I'll resolve this first. I know where to send you, right? Does the app request, and then that information, it will store it on this cache here. So that if a packet comes in and says, I'm going to this address, it goes, I've done it before. I know exactly where to send you, and I have the, app already cached, so I can send you directly. So that's like the fast switching, but it still has to do the first one via the CPU first. But Ceph doesn't even wait for the first packet to come through. Ceph instantly, the routing table is communicating with the fib. The routing table is downloading its information automatically into the fib. This one is automatically, proactively calculating the layer 2 part of it without you having to. So even if the first packet comes in, the A6 goes, hey, you're going to this address. The fib goes, I already know this. It's only when this one is like, hey, I have no clue. Or maybe there are some exclusions. Some exclusions would be some packet categories. One of them would be, for example, if a packet comes in where the time to leave is already expired. So maybe this is the 255th up and the time to leave has expired. So self will go, I can't forward you. What I'll do is I'll send you up to the software to generate a packet, that will say timeout and send it back to the person that sent the
Yeah,
link.
well, now I think the what reason what, and I'm sorry about that.
No
Why we
problem.
said
Yeah,
why I said cache
no problem.
actually was that in case you're doing things like NAT
Yeah.
or stuff like that, that the packet still has to be processed.
Mhm.
You understand?
Yeah.
Because like let's say you have you have NAT running, and the first packet that comes in, you have to make a NAT entry. So we need to send it upstairs to CPU to process it.
Yeah.
And once it's done, we'll create a path for it and just I'm not sure that I think we'll create a path for it and just put down the fib so that all subsequent packets just go boom boom across.
Yeah.
They are not sent to the CPU anymore.
Mhm.
But so if it's just basic routing, yeah, it does this. But if you're going to do other processing like NAT,
Yeah.
maybe proxy,
Mhm.
load balancing,
Mhm.
or you're using filters.
Mhm.
You understand? Access ACLs.
Yeah.
CPU needs to process it first, the first packet. That's what I was thinking of. I
Okay.
might be wrong.
I'll need
I
to
might be
research
wrong.
that one. Yeah. I'll need to research that one also. I'm not
Oh, they
sure
can still be
actually.
processed by ASICs. That's what Paul is saying.
Mm.
All right, that means I'm too old school, man. Wow,
So yeah, I'm not actually this one. I'm
they're
not
not
too
doing
sure.
that now.
Yeah.
Wow, I didn't know. I didn't know NATs can be processed by.
Yes,
It can.
actually, there's a table. There's a table actually that I was reading about. There's a table called the TCAM that can store stuff like access list and QoS. But I'm not sure of
Ah,
NAT. I'm not sure of NAT, but there's a table here called the TCAM on multilayer switches, which is
yeah, because
the ternary, yeah. but I know it can process access lists, with ASICs, and it can process QoS. I'm
Yeah,
not sure of NAT.
because access lists are usually triggered on the port itself, as the packets either going in or out of the port.
Mhm.
You trigger it works on the port. So I was thinking at that point in time, if it's like a fresh one that is coming in, it still needs to match the rule. How do we process it to see if it matches the rule? Because if you process it, then do we do translation tables for it?
Mhm.
You can expect for NAT.
Yeah.
You know what I'm saying? Access list, yes, I get, but
Yeah.
NAT, it gets triggered by the access list configured for that NAT,
Mhm.
right?
Yeah.
But we still need to do that translation table. How is that done? Is it so that's what I was thinking about. Maybe it's progressive.
Yeah.
Maybe it's just add one more for each one that comes in,
Mhm.
like in parts or whatever it is.
Yeah.
So
Yeah.
all right, yeah.
So that one, yeah.
Well,
So that one, I'm
things have
not.
changed.
That one, I'm not sure. I'm not too sure of. I think it's something that I'll need to research, and I'll try to come up with an answer next week. But I know it's still limited amount of expensive memory, and why everyone try to optimize access lists to not eat all memory. Yeah, yeah. I remember reading about that also in for the TCAM. That's like one thing that you could basically run out of memory, and then if it runs out of memory, it basically has to process them in software now. But again, yeah, again, we won't go into like too much details about this one. This is actually like CCMP discussion. But the thing is that it's good for us to be introduced to it. Yeah, nice one, Alex. Nice one. It's good for us to be introduced to it. So that if someone comes and says, even though Kerry is like, yeah, I'm CCNA, and someone comes and says, what about self? You can do as if, I'm a genius and go, yeah, self, I know self, and stuff like that. So you, so it won't, so that the first, so it won't be as if when you're having it, it won't be like the first time to hear it. It's going to be at least the basics of what's going on. So that's like actually talk about multi-layer switching. That's like basically everything to discuss. We first started with discussing about two kinds of switches, layer 2 switches and multi-layer switches, and discussing the differences between them. Then we discussed the different kinds of interfaces on a layer 2 by Mark, and talk about the different kinds of interfaces on a layer 2 switch. And that's only on a layer 3 switch, where we have layer 2 port by default. Using the no switch port command can be layer 3 port, and then we have the switch virtual interface, which are logical layer 3 interfaces. And then we talked about some certain layer 2 switch models. We just made mention of them, and some certain layer 3 switch models.
Well, I'm looking at the Cisco document that I posted, and
Yep.
it seems that there's a routing table, and then there's the FIB table, and then there's the adjacency table.
Yes, exactly. Yeah, it is. So basically, the routing table is in software. That's the thing. So the routing table,
Okay.
yeah, is the one in software. So the routing table is
Yeah,
the
because
RIB.
from what you were explaining, it seemed that it was in the FIB.
And no, it is in the FIB, but it's calculated in software first, then downloaded, remember, to the
Oh,
FIB.
okay.
So it's called the RIB, which is like the routing information base.
It's almost like if you have OSPF, it needs to converge first,
Yeah.
right?
Yeah.
Update its table. Then once it's updated and you have entries on your routing table,
Yeah.
you now put all that in the FIB.
FIB, yeah. And then it automatically updates the FIB also.
Yeah.
Yeah, exactly. So basically, the content of the rib and the fib should be the same. Well, not exactly the same, because this one will just contain like the network, the next stop address. Whereas this one contains like the routing protocol that calculated it. This one doesn't care about the routing protocol. It just knows this is the network, this is the next stop address, and this one does the layer 2 side of things. Okay, so then after that, what else did we discuss? Then we went ahead and discussed what are the justifications for or the reasons for using a layer 3 switch. And we
Uh,
mentioned, yeah, carry on, carry.
um, the what we were just discussing,
Yep,
right,
yep.
is that back end that you were talking about where the layer switch does the processing much faster.
The fabric. I'm not. Mawa, what do you think? I'm not sure. Is that the same as the fabric?
Well, we're not talking about. Well, there are two things.
The
We're
fab?
talking
No,
about the
actually,
layer
no.
three.
It's not the fabric. I remember the answer now. It's not the fabric.
Yeah,
So the fabric.
fabric is layer two, I think.
Yeah. Think about
Okay.
the fabric as this. The fabric is the backend that connects the switch ports together.
Okay.
Yeah. So all this, for example, if you think about it, when in the beginning we talked about the hub, right? We talked
Yeah.
about the hub as basically just one line going in between, right? And
Mm-hmm.
then all the port on the hub are connected to just this one line, right?
Yes.
But then on the switch, we said it's a bit different, and the difference is the collision domain. So all these ports are now, all these ports are now individual ports,
Mm-hmm.
right? But then still, even though they are individual ports, they have a backplane here that links them together. So that's like the fabric.
Oh, okay.
Yeah. So which is like does high level processing, like
Okay.
60 gig, 80 gigs, um, 80 gig per second stuff. So yeah, that's like the fabric. It's the one that links them together. Okay. So then we discussed the reasons for this, and then we discussed things like, we can use data channels in between our distribution and stuff like that. Yep, good one, Power. Power said Fabric is like Ethernet to access and in data center. Even though, even though I'm not too sure, but it sounds good.
Okay, I think it just did more damage.
It sounds good, and good point is always go with Power. Like it uses two different cables, like two coax, different technology. Yep. Sounds good. Okay. And then, yeah, then we talked about the thing that we still routers are still important, especially for things like there are some features that are still supported on this that are not supported on this one. And one of the ones that came out was like maybe ADSL connections. And then we talked about the reasons why this one process faster than just a normal typical router would do. It's because of the fabric, not the fabric, because of the ASICs, and we explained the way it works with the FIB table, the forwarding information based table, or a cache that's on the, yeah, or a cache, and then we've got the adjacency table, which does the layer two. And then we talked about how um, the routing table is calculated in software, starting something called the routing information base, then downloaded to the FIB. So yeah, so good one. So I think just to end today, because it's today's like a really quick and short one. I think we should just go ahead and let's configure multi-layer switch network, and let's just walk through that. So let's configure um, a layer 3 switch network. So let's have a layer.
Yeah.
So
Can I? Did you see my request? Maybe we could use that.
which one is
Oh.
that?
So I was asking that while you're configuring that especially when you're doing inter-VLAN routing,
Yeah.
that you enable debug IP routing, so we can see how the entries are being placed into it. Since it's static, it should only do maybe once or twice.
Mm.
It won't flood the whole packet. But I was just hoping you can turn it on so we actually see it coming.
But can we? I think could you not try to
I'm
do
not
it
sure if we can do it on
on
packet
packet
tracer. I
tracer?
didn't
Yeah,
confirm.
exactly. Exactly. I've actually not, I've actually not done it. Can share my screen. Show that we have two VLAN IP on layer 2 switch private. Okay, yeah. Please, Power, please. Power says he wants to share his screen to show because that was one of the things we talked about in the beginning where we said, at least from my own understanding, which I admit could be outdated, is that when you have a layer 2 switch, you can only have one functioning switched virtual interface. But Powell says he's got evidence to the contrary. So Powell, please feel free, please share your screen.
Well, that could just be packet tracer.
No, I think Powell's got the kit himself, right? I think Powell's got the kit. So yeah, it could just be packet tracer. It could be like with the one because we did it on 2960 and then it worked with the two being enabled. Yeah, okay, so we can see. So let me stop sharing my own screen so then we can
I'm
see.
looking at power screen right
Yeah.
now. Yeah.
So you can, if you're not seeing Powell's screen, just click on it, click on Powell's name, and it will show his screen.
Oh, okay.
Oh, okay. Oh, so Powell. So this could not. Powell said it's not packet tracer. Um. Oh, it's not packet server. So Powell, what we're saying is that could this just be a misbehavior of packet tracer?
Mm, no, depends on the iOS that's being used actually.
Um,
But well, yeah, but Power was trying to show us something else, right?
mhm.
Yeah, I don't think it's packet tracer too. Like I said, I've done it with GNS3, it works.
I know, but
So, and it
GNS3 is
depends on
multi-layered switch.
that's the thing. So,
But this one is layer.
depends.
We're talking about layer 2 switch.
Depends on iOS. If it has,
Ah,
if there are some that may give you maybe multiple management
ah,
interfaces. I've
okay.
seen that
Yeah,
in non-Cisco anyway. So,
yeah, okay. Yeah, it does make sense because otherwise, there won't be any innovation. Because if they're still doing the same thing that they were doing like 5 years ago, then they have to be like, yeah, and, on layer 2 switches now you can do five six
mhm.
virtual interfaces. It's layer 2 switch. Okay, nice one. I think next week, at the beginning of next week, that'll be the first thing I'll start with. So I'll go to research that and check which
Oh,
iOS no switch
yeah.
port doesn't work here. Yeah.
I think on
So
the same posting that you found in the first time when you were looking up if a
yeah,
layer 2 device can have more than one SVI,
yeah.
says that it can on the 2960s and the 3750s.
Let's see. Okay, so on the first one, right? The first one that I looked at.
I think so. It's
So
that
let me
one at
go.
the very bottom.
This second one. So let me share my
Yeah.
screen. Let me go. Ah, okay. So let's go. Thanks very much for that, Power. Thanks very much. So let's go switch screen one, share. So this one is the one you're talking about. So where did they
I
mention that?
think it's there and at the bottom. Yeah, right there.
It says just repeating the above. Really, 2960s, 30, yeah, 3750 is definitely a layer 3 one.
Yeah.
Can have more than
Mhm.
one for one default gateway. Two
Yeah, that's the
double
thing.
layer 3 device.
Because layer three will likely it should support more than one default gateway.
Yeah.
Layer two just should only have one default gateway.
Mm. Incop proxy hub that can be useful for situations like this. Okay, I'll do like a proper research on this one and then tell you my answer, just like we did for the VTP one, and tell you what I find out in
Okay.
the next hangout. So yeah, nice one,
Um,
nice one. Okay, so let's see. Let's try to. I'm sure that there are some really good labs on layer 3 switching online.